just a second. Let's look at another one. So y plus 4 over y equals 5, negative 5. Now this time the restriction is y cannot be 0, right? Because that's in the denominator. And then LCM, well, we only have one term, one denominator, which is this y. So my LCM is y. Now let's times y to everything. So this canceled. So we'll have y times y be y squared plus 4 equals negative 5y. That's quadratic. Now let's add 5y on both sides to make one side be 0. So add 5y, add 5y. Okay, so that'll be y squared plus 5y plus 4 equals 0, and let's factor. So if y plus 4 is 0, we get one solution, which is negative 4. If y plus 1 is 0, we get another solution, which is y equals negative 1. We can keep both solutions because the domain says y is not 0, but these two are not 0. So we can keep both. Okay. Now let's look at the next one. So this one's very similar. Okay, same thing. We find the restriction, so y can be 0 because that's in the denominator, and then LCM, we only have one denominator, so the LCM just y, and then let's times y to everything to clear my fraction. So it's gone. So I have y times y be y squared minus 14 plus equals 5y. Then you subtract 5y from both sides to move everything to the left side. You have one side be 0, and then we factor, so it'll be y minus 7, y plus 2 equals 0. And then, oops, if we let y minus 7 be 0, we have 7, y plus 2 be 0, we have negative 2. Okay, again, two solutions, and then we can keep both because our domain says y cannot be 0, but y can be anything else. Okay. Now the third one, it's a little bit different. Now same thing, you have to list the restrictions. So y cannot be 0, and then LCM, we have two denominators, 10 and y, so just 10y. So if you times 10y to everything, and then the 10 canceled, y and y canceled. So my left side is 9y, my right side is 10, and divide by 9 from both sides. So my y is equal to 10, 9. And then we can keep that because that's in the domain. Well, as you can see, this problem, you actually can just multiply across. So it's another method is you can multiply across. So another way to do this, if you have a single fraction, so use multiply across. If both sides, each side has a single fraction. Or a single rational term. So for this, you can just do this way. So it means 9 times y equals 10, and then y equals 10 over 9. See, it's much easier, right? But it only works for a problem if each side has a single fraction. If it has more than one, then it doesn't work. Okay, so the next problem, we can use this new method. It's just easier. Remember, a single fraction, we can do that. But let's first list the restriction. So x cannot be 0 because it's a denominator. And then instead of LCM and multiply LCM to everything, cancel, we can do this because there's a single fraction. So we can just multiply across, multiple, then divide by -5. So x equals 6 over -5, and that's it. So you see, it's just easier. Same thing for next one. Let's first list the restrictions. So n cannot be -2, and n plus 1 cannot be 0. So n cannot be -1. This is the domain. You have to find this first. Make sure your solution will make function be meaningful. Okay, and then because we have a single fraction on each side, so we can just multiply across. Then we have to FOIL. And then let's combine. So n squared plus 2n plus 1 equals n squared minus n minus 6. And now you can see n squared canceled. And 2n plus n equals -1 minus 6. So we can add n. And we can subtract 1. So just move n to the left side and then number to the right side. And then divide by 3. So n is -7/3. And again, because my domain says n cannot be, my domain says n cannot be -2, n cannot be -1, but n equals -7/3 is okay. Okay, and then let's look at the next one. So same thing. Domain says this one cannot be 0, so a cannot be -1, and a minus 1 cannot be 0, so a cannot be +1. So we have two restrictions in the domain. And then let's just do this because a single fraction on each side, so we can just multiply across and then it'll be simplified. Okay, so I'll subtract 6a from both sides, add 6 on both sides. So I have one side be 0, a squared minus 5a plus 6, and let's factor. And then we can let each factor be 0. So a minus 2 is 0, ab 2, a minus 3 is 0, ab 3. Well, let's compare. Well, a cannot be -1, +1, but this is okay. So it's no problem. Okay, so it's my two solutions. Now you can see if you have a single fraction on each side, you can use this method. It's just much easier. And then the next problem, it's not a single fraction. It looks much more complicated, but it's the same thing. Just remember I said harder problem means take more time. It takes more time. Well, before we list the restrictions or LCM, let's factor my denominator because one of them is quadratic. And we always need to factor the denominators to find LCM. It's easier, right? And also there is the least restriction. So there are two things in the denominator. So we know this cannot be 0, so x should not be 2, and then x plus 4 should not be 0, so x should not be -4. Now keep that in mind. These two things, they should not happen. So if your solution is one of them, you have to drop the solution. And then LCM. So LCM, as you can see, we have a denominator here. Now these two just the same. So the LCM, just the two terms here. X minus 2, x plus 4. Okay, this is my LCM. And then let's multiply the LCM to everything. I don't want to rewrite it, so I can just, when you multiply, you actually multiply to the top. Okay, it's just like if multiply a fraction, like 1/2 times 4, you times 1 with 4, right? To just the top, and then let's cancel. So it's cancelled, plus 4 cancelled, the whole thing cancelled. So we have x plus 4 times 2 left, and I have 1 times x minus 2 left, and we have x times 1 left. So distribute, and let's combine like terms. So 3x plus 6 equals x. So we'll subtract x from both sides, and then minus 6 from both sides, and then that give me, okay, 2x equals -6, x equals, divide by 2, -3, and let's compare with the domain. X cannot be 2, x cannot be -4, no problem. So we can keep this as our final solution. So this problem is much harder, as you can see, but it's the same. The extra steps, well, you have to factor your denominator so you can find LCM, and the restrictions a bit easier.